Hello everyone, I'm Michael from SDU Center for EnergyInformatics at the University of Southern Denmark. Today I will present the proposed DataPro framework, which is a standardized data understanding and processing procedure. And I also use a case study to show the implementation of each stages of this framework. This is the agenda for today's presentation. I will start from the motivation and background, then introduce the challenges of existing models. Next, I will discuss the details of the proposed DataPro framework. Afterward, I will use a case study to show the implementation. Finally, I will discuss and conclude the work. Now, I will start with the motivation and the background. In current energy informatics projects, there are multiple participants, both the data scientists and the industrial stakeholders will participate in the projects. There are also multiple data sources. It means the data are from different departments and management by, for example, both the software companies and the end users. And in energy informatics project, multiple technologies are used. In each stages, there are different tasks and subtasks, and for each task, we need different algorithms and methodologies to solve the challenges. So to keep the reliability and the repeatability of the energy informatics projects, we need a standardized process to manage the project. A standard data processing process should follow these four important criteria. The first one is reliable. It means each stage of the data processing process can't misguide the data processing task into a wrong direction. Next, it is repeatable. It means the data processing procedure should be a general one. All the stages can be used for multiple projects. Next is the flexible project planning. It means the data processing process can be understandable for both data scientists and the end users. Especially for the end users, because they are from different departments and some people don't have the data science background. So it should be easily understanding for all participants. Finally, all the stages should be documented well, and when the project is finished, all the files and the documentations should be stored and shared by all the project participants. Therefore, when organize an energy informatics project, the participants include the data scientists and the stakeholders, and standardized data processing procedure should focus on both the technology part and the business perspectives. There have been many existing data mining models, but they all have many challenges. For example, the CRISPR-DM framework is a gold standard in today's applications, but it still contains many disadvantages. Firstly, it mainly focuses on the business perspective because it was developed by the companies. In our DataPro framework, we highlight the data processing stages by adding more data processing stages in the framework. Secondly, the CRISPR-DM framework lacks the role of stakeholders, and in the DataPro framework, we use the legends to show the participants and their roles in each stage. Because of the lack of the roles of the stakeholders, the QuickDM can't show the communication mechanisms, but the DataPro framework can show the communication mechanisms in some stages, because in some stages, both the industrial stakeholders and the data scientists should participate in. Next, I will introduce the details of the proposed DataPro framework. The DataPro framework has 8 phases, which can be categorized into 4 stages. The legends represent the participants of each phase. Now we start from the first phase, the business understanding phase. In this phase, the stakeholder should determine the business objectives and evaluation criteria from a business perspective. The second one is the technical understanding phase. In this phase, the participants should translate the business objectives and evaluation criteria into a data science framework. It defines the input variables, output variables, constraint formulas, and quantitative evaluation criteria. The data understanding phase involves data characteristic understanding and data quality evaluation. This phase aims to identify and reduce the data quality problems in the next data preparation phase. There is a feedback loop between the data understanding and the technical understanding, because sometimes technical goals cannot be realized due to the data quality challenges. In the next phase, the data preparation phase, the collected data are pre-processed in this phase based on the insights from the data understanding phase. The activities in this phase include data cleaning, data transformation, and data integration. In the next modeling phase, many models are run using default parameters initially, and the model with best performance is selected. After this, fine-tuning of the parameters of the selected model is performed to optimize the model's performance. There is a constant feedback loop between data preparation and modeling, because new problems are identified during the modeling experiments, and then the data pre-processing strategies should be adjusted to improve the data quality. Next, in the implementation phase, the models are applied to a real-world environment, and this phase integrates the methods to the real-world system. The implementation phase relies on pre-processed data sets received from the data preparation phase for testing and validation. Moreover, continuous feedback loops between the modeling and the implementation phases are important to improve the model's performance here. Now we go to the evaluation phase. In the modeling and the implementation phase, the models have been assessed based on established technical evaluation criteria. Here, we evaluate the results using the evaluation criteria defined in the business understanding phase to ensure the technical accuracy and follow the business objectives. Finally, in the deployment phase, which is the last step of the data science project, here, the final report should be delivered here to record all activities of each stage. Next, I will use a case study to show the implementation of the proposed DataPro framework in an eco-driving project. Firstly, I should emphasize that In this paper, the technical details such as the algorithms and the evaluation criteria and the data quality is not important in this paper because we focus on the implementation of the DataPro framework, and all technical details of the case study has been published in another paper as a reference. The target of the project is to reduce energy consumption and greenhouse gas emissions in the public transportation sector in Denmark. The data set includes 4,006 bus trips, and here a bus trip is defined as a traveled way from the first stop to the destination of the bus plan in a specific time. The target variable in this dataset is the fuel efficiency. Now we start from the business understanding. Here we use the business model canvas to organize all the business information from the companies. And the value proposition is their business objectives. Here, the business objective is to reduce the CO2 emission and analyze the factors influencing the energy consumption in bus trips. In technical understanding, all the business perspectives are translated into the data scientist language. We show the input, output, evaluation metrics, and constraints here. Next, in the data understanding phase, we use the 6 V's big data characteristics framework to analyze the data quality and the data characteristics. It was published in another journal paper. And then in the data preparation, we handle the missing values and remove the duplicated timestamps. And we also integrate some features for better data processing. Next, I will introduce the modeling, implementation, and evaluation phases together. In the modeling phase, we choose the Gaussian mixed models clustering to categorize the fuel efficiency data into different clusters. Based on the evaluation matrix, 4 clusters are chosen. After the clustering, we analyze the data and show the distribution of the drivers and the routes in different clusters. Finally, in the deployment phase, we produced 3 reports for the data scientists, the end users, and the software companies respectives. For the data scientists, we analyzed the results of the data processing and concluded the advantages and the drawbacks of the project and the data management. And for the end users, we make the recommendations for efficiency operations. And for the software company, we make recommendations for the data collection and the software development. Finally, I will discuss and conclude the work. Compared to the existing data mining and processing frameworks, our DataPro framework focus more on the data preparation, especially in the data understanding phase. We use 6 V models to understand the data characteristics and the data quality. Next, it has flexible iterations. We highlight the communication mechanisms between the different stages, and all the stages can go back easily if necessary. Finally, it highlights the clear responsibility of the participants in each stages. To conclude, in this paper, we propose the DataPro framework, which is the standardized data understanding and processing framework. And we also use a case study in an eco-driving project to show the implementation of each stages of the project. In the future, we should provide more clear technical application details in the framework, which includes the opportunities to conduct iterations. Next, we will integrate more emerging technologies in the DataPro framework so that it can be used for more data science projects. This is the references and many relevant publications in this work. This is me. Thank you for listening to my presentation.